Okay, can you see this screen, please, if anyone of you can confirm me? Okay, Sadik. Thank you. Sabiuddin. Thank you. Okay, so to give you a recording notice, this lecture is being recorded. If you have any concern, you need to share with me. Okay, so so far what we have done, we started with the distributions of discrete random variable. Okay, and we have done uniform distribution so far, and we have also done the binomial distribution. Okay, these two are done so far. Now today we are going to study two more distributions of discrete random variable. This is called the geometric distribution Okay, now we will start with the basic definition and then we'll see how we identify using a mathematical model. If the events are Bernoulli trial and P the probability of occurrence in each trial the probability that the first occurrence will be at X trial. So I write it down X and T of H on the top. X trial is given by geometric distribution. Okay, so how we define it? If the events are Bernoulli trial and P is the probability of occurrence in each trial, the probability that the first occurrence will be at X trial is given by geometric distribution. It should be by here. It's given by geometric distribution. Okay, now I'm going on the next slide. Now, which this statement basically implies that there was no occurrence in the previous, now I'm talking about the previous. If x is my event here, the previous event should be x minus 1. So in the previous x minus 1 trial, okay, this is written as g of x colon p is equals to p times 1 minus p whole power x minus 1. Okay, now this thing 1 minus p here is what is the parameter of distribution, meter of distribution, in particularly geometric distribution. Okay, now if you recall from our last lecture, this thing 1 minus p, okay, let me do it here. This 1 minus p from our last lecture, this is the probability of non-occurrence. Okay, now we will do one example and see how we apply this concept. So I need to go on the next slide now, please. So let's do an example here, and this will elaborate more. So in a manufacturing unit, it is known that on average, one in every 100 items is defective. Now he's asking us what is the probability that the fifth item inspected is first defect found. Okay, so what is the example here? In a manufacturing unit, it is known that on average 1 in 100 items is defective. What is the probability that the fifth item inspected is first defect found? Now first we need to find out the probability, the failure probability P. So that is 2. We know that it is 1 in every 100. So it will be 1 over 100, which is 0.01. That is your failure probability, basically. Failure probability. Okay. Now, if I want to see what is the probability that there is no defect or non-defective, that will be 1 minus p, which is 0.9. This is indicating the probability of not defective. Okay. Now, in this statement, if you look on, he's asking what is the probability that the fifth inspected is first defects found. So this means the first 4 items are not defective. So that's what we will write here. The first 4 items are not defective. So for them, I have 0.99, and because there are 4 items, it will go to the power 4. Okay. The first 4 items are not defective. So, and the fifth one is defective. So G will be G at 5, semicolon, 0.01. P equals to, according to the formula, 0.01 times 0.99 power 4. When you solve it, you will get the answer of 9.61 into 10 raised to power minus 3. Okay, so this much is the probability that when you inspect the items, the fifth item will be the first defective item. Okay, now I'm going on the next slide. Now just like we were doing before, the formula for mean value or expected value in terms of geometric distribution is the 1 over p. Okay, and the formula for your standard deviation or the variance sigma square is also called as v of x, is equals to 1 minus p over p square. Okay, so these are formulas for geometric distribution. Now for your practice, folks, on page 79 of your textbook, Douglas and George, which is available on D12, you on examples 21 to 23. Okay, there will be a slight difference when you are reading it from the textbook, because I prepare your notes from different sources. This P in the textbook, instead of this capital P, you will see is using the small p. It's just a notation difference. There is nothing different in this. So formula and everything remain the same. Okay, I'm using capital P here, but the book is using small p, the same thing. Okay. Now the fourth distribution that we need to work on is the Poisson distribution. Poisson distribution. Now first we will use the definition of this Poisson distribution. The events which occur at any point in time or space can be modeled using Poisson distribution. Just keep in mind this is also for the discrete random variable. Okay, so the events which occur at any point in time or space can be modeled using Poisson distribution. Now, if the total time or space is subdivided to very small intervals, so that only one occurrence is possible in each interval then each interval can be assumed as a Bernoulli trial. Okay, if the total time or space is subdivided into very small intervals so that only one occurrence is possible in each interval, then each interval can be assumed as Bernoulli trial. I'm going on the next slide, please. Now, what does it mean? This statement means basically, for example, if this is an event occurring on a timeline, this is my starting point, and for example, this is my ending point, which is t. So after t0, the second will be t1, then we have t2, and up to so on. We will have number, and the time before this t will be t minus t of n minus 1. Okay, what does that statement means basically? If we divide these intervals into very small ones, so this will be my delta of t1, this will be my delta of t2. So these intervals, either delta t2 or t1, can be assumed as Bernoulli. This is based on the fact, as in Bernoulli trial, there are only two outcomes, as we studied last time. So what those two outcomes could be, it can either occur or it can occur. Okay. So in delta T2 or delta T1, it may occur or not. Okay. Therefore, this delta T2 is a Bernoulli trial. Now, what is the reason that I'm doing all of this? Because there is a parameter in Poisson distribution that we need to introduce, which is called as the lambda. Now, it means if the mean occurrence rate of an event is lambda times event will occur on average lambda t times over a year. Now just keep in mind this unit, this is the time unit, okay? This is my time unit. So it can be days, it could be month, or it could be any time unit. And accordingly, let's say if I choose a month here, so it will be lambda t times over a month basically. So the units needs to be consistent. Okay. I'm going on the next slide, please. Okay. So the probability of an event occurrence in a time interval would be lambda t over n. Okay. So for the Poisson distribution, the probability is defined as occurrence in t time is equals to nx times lambda t over n. This whole power will be x times 1 minus lambda t over n, and this whole power is n minus x. Now for all of this, we will take a limit that your n approaches to infinity. Now this thing is we discussed last time, which is the combinatorial here. And why we are taking up to infinity? Because it will be valid for the small time interval. So when you apply the limits here, you get lambda t power x over x factorial time e power minus lambda. Okay. Now this formula is in terms of your time, but if you want to take it in terms of average number of events, in terms of average number of events, diameter. So this will be P of x occurrence. Now we are not talking about the time here in this formula. It is based on the number of the events. Will be lambda power x over x factorial times e power minus lambda. Okay. So this is when you have the time involved, and this is when you have the number of events involved. Okay, I'm going on the next slide, please. Now in Poisson distributions, Poisson distribution, these formulas that we use. The mean formula is lambda t. Variance formula is the same as the mean formula, which is lambda t. Sk is 1 over lambda t, square root of this. Kurtosis is 1 over lambda t. Okay, so these are the formulas for your Poisson distribution. So I need to go on the next slide, please. Now we will do an example here. Okay. From the records of the past 50 years, it is observed that tornadoes occur in a particular area, an average of 2 times a year. What is the probability what is the probability of no tornadoes in the next year? Okay. Now the second objective is in the next 50 years. 50 years. The third objective is what is the probability? What is the probability of exactly two tornadoes in next year? Okay. So what is the question here? From the records of the past 50 years, it is observed that tornadoes occur in a particular area an average of 2 times a year. What is the probability of no tornadoes in the next year? In the next 50 years, what is the probability of exactly 2 tornadoes in next year? Now let's go for it. First thing that you need to find out is your lambda here. So the lambda is occurrence, rate of the occurrence basically. So if you see here, we have 2 times per year occurrence of this. So my lambda will be 2 per year. Okay, I need to go on the next slide, please. Now, as the event is occurring over the time, so we use Poisson distribution. Poisson distribution. Okay, so just to give you the formula reveal that probability of x in time t is equals to lambda of t power x over x factorial. That's what we were doing in the previous slides. E power minus lambda t. Okay. Now let's come back to our question statement here. Now in the first one, he's asking what is the probability of no tornadoes. So this is something indicating me the value of x should be 0 here in the next year. So this will be the year 1, which is t1. So for the first objective, I'm interested to find out the probability at x is equal to 0, which means no tornado, in t is equal to. Okay. So I know the lambda, which is 2 times. I'm interested for t1. So the t value here is 1. My x value is the 0. I'm concerned with the no tornadoes at the moment. So my x will be 0 over 0 factorial, which is x factorial, multiplied by e power minus lambda, which is 2 times t, which is. So when you solve it, you will get your answer as 0.1315. Okay. For your information, 0 factorial is 1. Now, let's come back to question again for number 2. Now in number 2, he was asking me in the next 50 years. So this means to say the time will be changing to 50 only. Okay. So in the part 2, what we are interested to find out the probability that there is no tornado in 50 years. T is equals to 50 years. Okay. So the same formula as we were doing before, the lambda value is 2. This time my time is 50. Whole power x will remain the 0 over 0 factorial times e power minus lambda, which is lambda is 2, times t this time is 50. Okay. When you solve it, you will get the value of the probability as 3.72 into 10 raised to power minus 44. Okay. Now let's start with the third one. Okay. Now in the third or the last one, he's asking what is the probability of exactly 2 tornadoes. So this means to say the value of x should be 2 at this in this in the next year, which is t is equal to 1. So what I'm interested to find in my third objective, I'm interested to find out x is equals to 2 in t is equals to 1 year. Now using the same formula as we were doing before, the lambda value remained 2. My t value is 1 at the moment, and whole power, the x this time is the 2. Okay, over 2 factorial times e power minus 2, which is lambda, and the time is again 1. So when you solve this, you will get sort of 0.271. Okay, so these are all your answers. This is part 1, this is part 2, and this is part 3. Now I'm going on the next slide, please. Okay, now we will do one more example here. For a large construction project, the contractor estimates that the average rate of on-the-job accidents is 3 times per year. The first objective is what is the probability that there will be no accident in the first month of construction. Okay, the first objective is what is the probability that there will be no accident in the first month of construction, and in the part B, what is the probability only one out of the first 3 months of construction is free of accidents. Okay, so I'm going to repeat it from the start. He's saying for a large construction project, the contractor estimates that average rate of on-the-job accident is 3 times per year. What is the probability that there will be no accident in the first month of construction? The second objective is what is the probability that only 1 out of the first 3 months of construction is free of accidents? Okay, folks, I need to go on the next slide, please. Now, the first thing that you need to find your lambda from your question statement. Now, there is a little bit change here. Now, if you look back on your question statement, it is saying that this is my lambda for sure. This is 3 times per year, of course. Okay, this is my lambda. But if you look on your that we need, he's talking time in terms of the month. Okay, he's asking in the month, first month, 3 months. So we need to make the unit consistent. Now there are 2 ways. Either you can convert these months into years, or the easiest way is we can convert this year units in terms of the month. So I'm going with the later option. So I know that this is my 3 per year. If I want to convert into the months, I divide it with 12 and I get it 1 by 4 months. Okay, you have the units consistency. So one thing I always say, if you take care of the units, units will take care of you as well. Okay. Now let's come on the first objective. So he's asking what is the probability there will be no accident. So this is the event here. So the X value should be 0. Okay. In the first month of the construction, by this I mean to say the time is 1 here. Okay. So we need to find the probability where X is equal to 0 and time is equal to 1. So we are interested to find out the probability where your X is equal to 0, there is no accident, and the time is to 1. That's what we need to find out. Now we know that as a general formula is the lambda of t whole power x over x factorial times e power minus lambda t. This thing will be, when I plug in the values here, I know what is my lambda here, which is 1 by 4. Now the units are consistent. You need to take care of your units so that they can take care of you. So the time here is 1 and whole power will be x. X is 0 here. Divided by 0 factorial times e power minus 1 by 4 times 1. So when you solve it, you will get 0.7788. That's your answer here. Okay. Now in the part B, he's asking what is the probability that out of first 3 months of the construction is free of the accidents. Now this thing we can solve using the binomial distribution, the general formula of the binomial distribution, where we have P of x is equals to 1. We are interested for first 3 months, and the probability of no accident is 0.7788. And how we do that? Sorry, this should be B actually. Fix this. Okay, good. This is our B here. So this is equals to 3 of 1, 3 out of 1, and times the value of your Px at 0 is equal to 1, 0.7788 power x, which is 1, times 1 minus 0.7788, 1 minus p, and here we have the power 3 minus 1 basically. So when you solve this, you get 0.114. Okay, and that's your answer for part 1. This is your answer for part 2. Now folks, in your textbook for your practice, go to page 92. Try to attempt example 32 to 33. Okay. As I said last time, when you are attempting the example, just look on the statement and try to solve yourself. And if you are going at wrong, just see where the correct solution should be. Okay, folks, I'm going to stop it here and I will take your questions if you have any. Yes, folks, do you have any question for me, please? Okay, so Adi is asking month. Okay, your first question is why mean and variance are the same for Poisson distribution? Because this is the profile actually. When you develop the profile for them, you will see that they are equal in the values, in the mean and the variance. This is asking month is in the denominator. I didn't get you what you mean by that. Scene has a question. Would you be able to work in the years instead of months? Do you mean to say the other like the opposite what I did? And yes, you just need to take care of the units. You will get the same answer. Where you showed the summary of the Poisson distribution formula. Okay, asking, can you please redisplay the slide where you showed summary of the Poisson distribution formula used? Okay, let me go back here then. Okay, somehow my system seems to be hanged up. Just give me 1 second, guys. I will fix it. Okay, good. So you want me, I think this one, that's what you need, Dawn? Okay. Okay, so the next question is, Hadi is asking, in this slide, in the first line, month should be in the denominator, right? Yes, it's just the unit conversion actually. You need to convert your year into the months. Okay. Folks, more question for me for today? Okay, Don, can I change the slide now if you are okay, good. If you don't have any question, folks, I will just like to give you some help in your assignment, which is posted over there. Now this system again has some problem. Okay, folks, I just want to give you some help in your 4 of the assignment. I'm not supposed to provide you the help, but don't tell anyone, please. Okay. So this is basically the revision of your integration, what you have been doing, and you might need this in the question 4. So the basic formula for integrating x of n, this will just give you a revision of your integration. So this is the formula that you used to have x power n plus 1 over n plus 1 for integrating n power d of x and plus your constant of integration. Okay. Now, if you have some function like this, 1 over x, where you have the d of x, you will see that this x has a derivative 1 on the top, taking the integral, so it will become the natural log of x. Okay. Now, if I multiply it with any constant number, that will remain the same. For example, if it is 2 by x, integral of d of x, so that is the 2 integral of 1 by x into d of x. Now I can write it down as the 2. This is again, this thing is same as before. This is the natural log of x, ln of x, and plus c, the constant of integration. Okay. Now if I go a little bit complex integration, this is 1 over 1 plus x of d of x. Now this function at the bottom here, this is 1 plus x. It has the derivative. If I take the derivative, one derivative is 0 and the x derivative is 1, which is 1 here. So the derivative is on the top, and this is again the same as the natural log of 1 plus x, and plus of course the constant of integration. Okay. Now things become a little bit complex when you have something like this. Whole power square or the cube or whatever. How do you solve this? And especially when you have the limits from, let's say, 0 to infinity. I'm going to use the next, please. Okay. So this is 1 over 1 plus x whole square. into d of x. Integral you take from 0 to infinity. Now how do you solve it? I mentioned you something in your question for help. You use the integration by substitution. Now in the substitution, what we do basically, we assume our given problem in terms of another variable. By that I mean to say, I take let's say 1 plus x equals to u, another variable. You can take it z, y, q, p, whatever you like to take it. Now the advantage here is that I take the derivative here, du, which is equals to, now the derivative of 1 is 0, it's constant, plus the derivative of x is the d of x. So du is basically is equal to d of x. Now this thing, when I substitute this definition into this one, will become integral, will remain the same, 1 over, this will be our u and the scale. Now this d of x should be replaced by du. Now there is one thing that you need to take care here. These limits are associated with x. Those are not associated with the u. So using your substitution equation, you will identify the new limits for your u variable. By that I mean to say, this is my x. If I put x is 0, or at x is equals to 0, what will be my u here? U will be 1. Okay. Now my second definition is infinity. So at x is equals to infinity, my u will become again infinity. So now in the new variable, which is a substitution, my limit should be for the new one. So this is x is equal to 0. Instead of this limit, I will use my u is equal to 1 here. And this is infinity. At x is equal to infinity, also infinity. So I take the infinity here. Now what is the advantage of using this substitution? Because it allows me to integrate this function very easily. Okay, this is 1 here. How we do that? If you think, I can write it down as integral of u power minus 2 into du, integral from 1 to infinity. And I just stated on the last slide, if you have a function with x over n of d of x, its integral will be x of n plus 1 over n plus 1. So now I can solve this. That's u of negative 2 plus 1 according to the formula over, I divide it with the power. And because I have the integration here, I need to put my limits here. This is what I was talking about, that you need to know how to apply your limits here. Okay. Now we solve it. This is u power minus 2. Minus 2 plus 1 give you u power minus 1. And this will become the minus 1. So limit from 1 to infinity. And this negative 1 can come out. And I still need to apply my limits here. 1 to infinity. Okay. Now we just need to apply our limits here. I know that this is, okay, let's do 1 over u, limit from 1 to infinity. Now in the next step, I can apply that. This is upper limit applies first, and then we subtract and apply the lower limit, which is 1. Okay, and this minus 1 I'm missing here. So it will be minus 1 times this term will be 0. So you have 0 minus 1, and you get the answer of 1. So this is how you can use the substitution in order to solve your problem. Now this is the solution of your question number 4, but you will feel the same kind of the integral when you have developed your equation. It will be similar kind of this. It's not the same, but it will be similar kind. So this is how you use the substitution method. I just wanted to give you some revision on this. Okay. Folks, is there any more question for today? Okay, good. And I just need to make one announcement. If you are submitting your project and you have more than one person in the group, it's only one person who need to submit the project outline, not everyone. Okay. Okay. So if you don't have any question, folks, I will let you go and have a very good weekend. And I will see you on next Tuesday. Thank you very much.